So good afternoon, everyone. Welcome to this edition of the monthly NITheCS Mini-school. My name is Francesco Petruccione, and I'm the event director of NITheCS. This month, as you know, the Mini-school is dedicated to research software engineering, various aspects of it, from research to careers. Yeah. And today we are very lucky to have Dr. Martin O'Reilly with us from the Alan Turing Institute. And I will ask now Dr. Kim Martin, that most of you know already because she is responsible for organizing this series of events, to please introduce Martin because she knows him much better than I do. So Kim, please, if you're welcome to introduce Martin, and then we hand over to Martin for the lecture. Thank you.
Thanks very much, Francesco. Welcome everyone to this third and second to last talk on the RSE series of talks that's been graciously hosted by NITheCS. It's every Wednesday this month, and the previous two talks in this series given by Jeremy Cohen and myself are now up on the NITheCS YouTube page, so they can be watched there. Martin is going to be giving his talk now on the value of research software engineers for reproducible and applied research, and then the following week will be a talk by Michelle Barker that's going to be talking more, I think, on policy type matters. Just before I introduce Martin, I want to highlight, as I've taken the opportunity to do at every talk, that this is an invitation for sort of people who this role, the RSE role, speaks to, who are in Africa, to join this movement that started in the UK 10 years ago, but has now spread internationally. And the best forum for you to do that, if you are an RSE in Africa, or actually if you're a research systems engineer, so more on the hardware side in Africa, is to join RSEs Africa, which is the platform that has been founded in 2019 and is going from strength to strength. So just to introduce Martin. So Martin O'Reilly, I'm reading this because I don't want to make any mistakes. Martin O'Reilly is Director of Research Engineering at the Alan Turing Institute. He leads a group of research software engineers, research data scientists, and research computing engineers who collaborate across the Institute's research portfolio to help researchers bridge the gap between research and practice. This is done through the development and deployment of reusable software, reproducible analysis pipelines, and flexible research computing resources. His focus is on using good software engineering practices to increase the impact of research software and data science analyses by making these reusable, reliable, and robust. He also has a strong interest in reproducible research and is working to improve the tools and working practices available at the Turing to make it easier for researchers to work reproducibly. Martin has a PhD in computational neuroscience from UCL and a master's in artificial intelligence from Edinburgh. His experience in developing software, managing software projects, and managing technical teams spans both the research and business sectors, having spent several years doing this in the commercial sector between stints in academia. So I'm going to hand over quickly to Martin. I'm looking forward to this talk as much as I'm sure anyone else here is.
Okay, so can you see my first slide in sort of?
Yep, yes, I can see it.
Okay, excellent. So thanks for the kind introduction, Kim. You've sort of covered, I guess, most of my first couple of minutes. So in the previous two talks, you sort of heard from Jeremy and Kim about what the research software engineering role is, and about various models of supporting research software engineering at an institution. And I've been sort of with the today I'm going to sort of talk to you about how we sort of do that at the Turing, and how we sort of leverage our research software engineering capability to advance the Turing's research, apply that research in practice, and ensure our work is reusable and reproducible, so that others can trust it, easily reuse and build on our work, for their own endeavors. And I've been with the Turing since we started 7 years ago, and not in this sort of role all the way through, but I've sort of helped build and grow that team, and I've sort of built and grown a similar team in industry beforehand. While I talk about, I'm going to talk about sort of what things are at the Turing. I think those of you who were here for Kim's talk last week will recognise sort of quite a lot from the conversation she's been having with other research software engineering groups around the UK. So I'm going to talk about three things today. I'm going to talk about the research infrastructure teams at the Turing. So we've got a central research engineering group, but also some other roles around the Institute. I'm going to talk about the work that our research infrastructure folk do for the wider data science and AI community. And then I'm going to spend a bit of time talking about some of the things that have been critical for us in building and sustaining these sorts of teams for these sorts of research infrastructure roles, which sort of tend not to fit into the sort of classic sort of postdoctoral pathway in terms of sort of reward and career progression. So in terms of research infrastructure teams at the Turing, the main one is the Group I lead. We've got a big central team. It started out as 7 years ago, and it's sort of 44 now. And we've got three strongly overlapping roles in that team. We've got research software engineers, produce reusable, robust software to help our research be more usable by other people. We've got research data scientists who build reproducible analysis pipelines that allow people sort of to trust and kind of reuse that analysis. We've got research computing engineers, so these sort of research infrastructure roles. System engineer, I think, is how they're sort of referred to in the African RSE community. But these are the folk who sort of enable the leverage of research computing capability to support research, so much of which is critically dependent on that nowadays. But we've also got other research infrastructure roles around the Turing. So we've got some data wranglers, and I think these sorts of roles exist in lots of organizations. So these are folk who are specialized in sort of understanding data, sort of cleaning it, making it research ready, curating it so that it can be reused by others. And then there's sort of two roles that we pioneered at the Turing in conjunction with our Tools, Practice and Systems program. One of these is a research application manager. So those of you who have experience of software in industry, this is quite analogous to a product manager role. So the idea here is to think about when a piece of work we're doing at the Turing becomes something that should move from being a sort of Turing project to a community research product, something that enables and supports a wider community and needs to be driven by the needs of that community and extended out to contexts that we haven't experienced ourselves at the Turing. And if you can think of, if a research software engineer's job is to make sure that software is reusable, a research application manager's role is to ensure that it is reused and that its development is driven by the needs of the wider community. And community manager roles, these exist across the open source ecosystem, and we've pulled them into the research context. And these are sort of focused on opening up that collaboration base, opening up that contribution base to ensure that folk outside the Turing and the original project team can contribute to the code base, to the documentation, to supporting the community as a whole and building the research product. So I'm going to focus mostly on examples from my group, the research engineering group, but as we get to some of the work we do for the wider community, this is definitely sort of work that's involving research infrastructure roles from across the Institute. So there's three things we primarily do in the research engineering group at the Turing, and a huge part of our role is supporting the Institute and bridging that gap between research and practice, and ensuring that the work that that our researchers are productive and effective, and that the work they do can be used by others. Then we do some research infrastructure stuff for the Turing itself, and some of these have been the jumping off points into some of these wider community sort of roles, but this is that enabling sort of work to support the wider research community, not just the people we're directly collaborating with on research projects. And we work with the Turing and wider community on sort of skills and communication and community and public engagement. And in terms of sort of this bulk of our role, so about 80% of the team's time is spent working on, hands-on collaboration with researchers on research projects at the Turing, and they generally form one of two kinds. So about half of our community are AI and data science methods developers, and so this sort of work is about helping them take something that was promising in the lab and bring it into contact with reality and turning it into something that could be used outside of the research sort of ecosystem. And the other half of our community they're researchers, but they're not AI or machine learning or data science methods researchers. They're folks interested in sociology or digital humanities or applying these sort of methods in environmental sciences or sort of across their research interests. And for these, this is very much like the practitioner community. They use these methods as tools, and our role there is to sort of help them find and leverage the tools that are sort of at the cutting edge of the research frontier and apply those in their own research practice. And a key thing across all of this and across all the research infrastructure roles that the Turing, as both Jeremy and Kim sort of touched on before, is papers aren't the primary sort of output for these sorts of roles. Our output is software that can be used by other people. It's analysis that can easily be reused and extended by others, and it's reproducible research infrastructure that let other people sort of deploy and scale our work. So I'm going to talk about 4 projects that so we've been involved with over the years that I think highlight the value that research software engineers can bring in a hands-on role. And then I'll finish up by talking about those other 2 boxes, the research infrastructure and the skills and community aspects. So one of the projects we were involved with over a few years was one looking at urban air quality in London. And its primary thing is that there's a network of sensors around London. There's only about 100 of them at very high resolution. So they give data sort of minute by minute, hour by hour. And then there's about 1,000 that basically just accumulate a single number over the month and very, very sort of coarse. And there's a few mobile vans. But if you sort of build in traffic, building geometry and weather, you can sort of do really good nowcasting to sort of infill what air quality between these sorts of sensors is like and get a very high resolution sort of map of air quality in London. And what we did was work with researchers to deploy these models for the sort of London local government to use. And that involved making some reproducibly deployable data infrastructure that would pull this data in every day, run the models, and then present the outcomes of those models as sort of data layers that were easily interpretable by the folks who were making decisions. And during the pandemic, one of the things that became sort of really important was understanding the effects of these sort of social interventions, so things like lockdowns and restrictions on movement. And one of the feeds we were using were traffic cameras to identify sort of the level of traffic on streets. And we were able to pivot and deploy a kind of parallel infrastructure here to use those cameras to identify the sort of types of traffic, foot traffic, bicycle traffic, buses, cars, taxis, to understand what mobility was like in London under the various kind of regimes and to what extent that these lockdown measures were having the desired effect. And I think that's a really sort of great example of where putting that work into sort of make the sort of work reproducible and connect it to reality sort of allows you to sort of quickly and reliably repurpose it. This is a very sort of high stakes, high pressure, fast moving sort of environment, but because we've done the work before, we were able to kind of quickly move while sort of relying on the the quality of the analysis that was coming through. Another project that the team's been heavily involved with is AI for air traffic control in conjunction with the UK's National Air Traffic Service. And a key part of what we've been doing there is building a digital twin of the UK airspace using sort of historical data, and we're able to simulate air traffic under a range of conditions. And we've been working with the researchers to develop AI agents that can sort of take on some of the responsibilities or provide sort of support for air traffic management. And we've been and then the wider team has been sort of working on human AI teaming. So how do these agents and human air traffic controllers work together, and how do you evaluate sort of how that works? And we've just finished a trial over the summer on simulated airspace of air traffic controllers and some of these agents kind of working together, and that's been a great source of sort of feedback in terms of sort of what works and what what's helpful for the humans, as well as sort of figuring out what it means to be good for these agents. And the idea then is that this framework can be sort of used almost competition style for the wider research community to engage and develop models of their own. And this one's, I think, a great example of both where the software infrastructure is critical for the work, but also the research software engineers are getting involved in some of the science itself, some of the research, some of the development of these agents. Another big project we sort of ran over, we were involved with at the Turing over sort of 5 years or so, just finishing up this August, is Living with Machines, which is looking at the societal response to the Industrial Revolution. And it's involved, applying data science to scaling the humanities. And, in many ways, the so-called hard sciences are sort of ahead of, the digital humanities in working with scale. But I think a really interesting from this project is that when it comes to handling uncertainty with data and, what is truth, how do you handle observational data that you can't go back and resample? Actually, the humanities are sort of further ahead than the hard sciences. And we've seen a lot of new methods development in this project, and it's been a sort of really good example of where tight collaborative co-creation between sort of the methods researchers, the domain researchers, and the research software engineers has resulted in something that's sort of much greater than the sum of its parts. And some of these methods have gone on to be used sort of in other fields, and I'll come on to that next. And the final project I wanted to talk about is SciVision, and this one's firmly on the researchers as tool users end. So the purpose of this project is to apply existing machine learning sort of vision techniques to science, and what you tend to have in this area is that particular areas of science have taken particular techniques and made them useful there. But with a little bit of extra work, you can translate those across disciplines and make these methods much more widely accessible, both in terms of doing the extra work to make them applicable in different problem domains, but also adding sort of that extra work around documentation, around testing, around robustness to sort of make them tools that can be used independently by the research community without the support day-to-day of research software engineers. And again, this has been a sort of great example of research software engineers and the researchers themselves working really closely together to kind of define sort of what those problems are, what the promising tools are, and sort of what changes would be needed to kind of make those effective in new domains. So those are sort of, I think, 4 exemplar projects that sort of show kind of what hands-on working together value looks like for research software engineers and researchers collaborating on research work and on applying that research in practice. But in terms of, as Kim mentioned in her talk last week, there's only so much you can do sort of working, there's only so many research software engineers, and there's only so many projects that sort of can fund a research software engineer for a significant amount of time to work with them. And actually a huge part of the impact of research software engineers at an institute is in the sort of general upskilling and support and enabling of the community. And we see that sort of happening in a variety of ways at the Turing. And sort of one key part of that is the research infrastructure. And for data science in particular, so much of the research nowadays relies on computing, and often sort of quite large scale compute or some novel accelerator architectures for machine learning. And we support the Institute's research platform. So the Institute is cloud first itself, but we also support access to various national platforms and sort of big clusters with GPUs. And a lot of the application areas we work on in finance, in administrative data from government, in health, work with very sensitive data, and even when you've de-identified it, it's still sort of not safe enough to have bumbling around on the internet or on people's laptops. And so one of the facilities we run for the Institute is a trusted research environment, and I'll talk a little bit more about how that's expanded to become an infrastructure project we've been doing for the community as a whole. But this is what enables us to work safely with sensitive data while applying modern data science tooling at scale, while still being able to use all the collaboration tools that we're used to outside of these environments, and being able to, it's cloud-based for us, so being able to apply it on these sort of cutting-edge accelerator hardware. And then the final thing, again, I think it was touched on last week, is code repositories. A critical part of the work that we do is making that work open and available to other people. And a key part of that is pushing that openness and that collaboration as far down the process as possible. It's great to make everything open at the end, but it's an awful lot of extra work. The more you can do in supporting the wider research team in sort of working sort of agile small a, sort of practices and sort of building evaluation and documentation in as we go, and making that sort of early code available to the wider community, the sort of better the quality and the feedback loop is. So all the work the team does is open source, and most of the work the Institute does is, and we maintain the Institute's sort of GitHub organization and within the trusted research environments as a self-hosted sort of version of that. And then the last thing that we sort of do to support the research community at the Turing is around sort of skills and knowledge sharing. So there's a range of sort of knowledge sharing seminar series. The team itself does a weekly tech talk. Our research application and community manager colleagues do in the Turing way do a regular collaboration cafe and knowledge sharing sort of seminar series. We provide training for researchers at the Institute in sort of baseline research software engineering practices and data science practices and reproducible research and sort of using tooling like GitHub and so on. We support placements from sort of government, other research software engineering groups inbound into the team to sort of help with two-way knowledge exchange. And this isn't just about getting experience of particular technical expertise into the team. This is also about sort of sharing that experience of working practices, because as a field, I think we're still discovering what many of these sort of practices that have become, sort of leading to best practice in industry, how those sort of work in the research context, both as research engineering professionals ourselves, but also then as good enough practice for the wider research community. We're involved in some of the Institute's public engagement. So we started the Institute's podcast, and we also run a series of Turing data stories, which are reproducible, inspectable pieces of analyses about an interesting sort of problem, whether it's sort of baseball or elections or something like that. But that's sort of well documented and runnable online by members of the public to give them an insight into how sort of data science sort of works in their day-to-day life and help improve sort of data literacy in general. So some of the things we do have sort of expanded out to be supporting the wider data science community. So one of those is research computing. So we've been cloud first in our compute since we started, and we've been supporting others in sort of how to do that and how to leverage that effectively. We support the wider AI community in accessing some of these national compute platforms for working at scale. And we've been informing the development and investment internationally of the sort of next generation of compute for AI and machine learning through things like our review of AI infrastructure needs and sort of benchmarking activity on candidate sort of new platforms. And it's been great to see a lot of that work sort of feed into the sort of recommendations from the National Future of Compute report. The other thing is that as we developed a safe haven for ourselves that was sort of scalable and supported modern data science tooling, and we've made that open source and available to others to use, and it's now been used by other organizations. We've co-founded a wider UK TRE community to bring sort of 200 odd people across 30 organizations together to sort of connect a very disconnected ecosystem. And we've been doing sort of work on defining sort of what common community standards are so that we're not all reinventing the wheel and having the same conversations again and again between data providers, trusted research environment providers and researchers. And then the third area that I think has been one of the widest impact things from the Turing is the Turing Way. And this is a good practice guide initially for reproducible research, sort of stemming out of a conversation at the Turing about what should baseline reproducibility practices look like at a National Institute for Data Science. And then since then, it's expanded onto sort of project design and sort of, again, small a agile project management. communication, how do you sort of communicate your research, collaboration, sort of what are those practices of doing sort of team research together, where you've got different shapes of people working across the collaboration, and ethical research, which has fed into the Institute's updating and evolving its own sort of ethics process. So the last thing I want to talk about is a little, I guess, insights from what we think has allowed us to kind of grow sort of these sorts of roles at the Turing in a sustainable way. But again, many of these will be familiar from some of the highlights that Kim has pulled at, across her conversations with other research software engineering groups. These fall into sort of three key areas. They're having a sustainable operating model. How do you ensure that you can fund and run the team and grow the team sustainably, even if the mix of things that you're working on is has a wide range of different timelines? How do you support career development so that you can attract and retain and sort of build capacity for these roles, which are still there is more demand for research software engineers and other roles than there are people sort of doing them. And the third thing is team culture. How do you make a place where people feel that they're doing good work, that they have some control over what they do, and that even though you can't compete with industry on salary, you can provide sort of other benefits that make it a kind of sticky and attractive place to work. So in terms of an operating model, a key element is cost recovery. We were extremely fortunate at the Turing. Our first 4 hires were permanent and funded by core. So there was no pressure to cost recover immediately, but we got an initial cost recovery model working within our first 6 months, and that's been critical to be able to grow the team at pace alongside the growth of the Institute, and to continue to make permanent hires into the team, even though the work that comes in has ranges from 3 months to 3 years. And key elements of this sort of model for us have been using a single sort of blended cost rate across the team, and having a model that doesn't require us to name specific individuals on specific grants, and a model that allows us to recover overheads for the team, for the work the team does, but not have that be a critical part of what success looks like for the team. So if the Institute decides this range of funders are acceptable and the work is valuable, then whatever those overheads are, we recover them into the Institute, and that sort of really helps make us cash positive. But we're not incentivized to preferentially sort of work on the things that attract more overheads. And this is sort of one of the challenges I think other groups have. If you're trying to find space within an existing organization, it can be really, really hard to get any sort of underwriting. And depending on whether you're in professional services or you're on the research side, whether or not you can attract overheads sort of can vary quite significantly. Another sort of critical aspect, I think, is this mix between sort of project and service work. But the vast majority of the team's time is spent hands-on working on the Institute's research and on applying that in practice. But again, the team can only work on a fraction of the Institute's research, and if you want to sort of have the most impact, you've got to be able to kind of spend some of your time supporting the kind of researchers at the Institute more broadly, whether that's through the infrastructure platforms or whether that's through training and skills transfer. And there's also a side benefit that it raises the profile of the team. Everyone sort of knows you, and therefore your sources of future work are quite broad, and it gives you a sort of baseline income, I guess, when you're trying to kind of have those conversations about how fast you can scale the team sort of in response to demand. And then the sort of final element is I think super critical, which is job security. And this one can be sort of super tough, but it's, we've been super fortunate to be able to start with and continue to support as we've sort of grown tenfold permanent roles at the Institute. But even going from individuals named on individual grants to a pool of people, with a rolling 2-year security window is a huge step. And sort of combining a few of these things, we've seen several groups get a very small amount of, underwriting, maybe it's 1-2 FTEs, and suddenly they can go from being like just about managing to be 3 people, costing everyone onto individual grants, to being 8 people and then 18 people, because they've got just that additional bit of flexibility that allows them to sort of smooth out the sort of ragged edge of individual grants and to more effectively pool that sort of income over space and time. The other thing that I think is really sort of important is, well, again, we've been fortunate at the Institute to sort of pay reasonably in the academic context. We are, miles out, like 2 or 3 times lower than Google, Facebook, and the banks. And I'm not entirely sure where we are in this big middle, sort of, Sainsbury's or Tesco's or Marks and Spencer's. What do these organizations that have data science and software engineering teams, but that's not their product. And I think our goal would be to be competitive with them, but in academia in general, there's quite a restraint on pay. And I think career development is one of those areas that sort of really makes a difference for people. And especially as their alternative is being in industry, where there's generally a good career pathway, or in academia, where there can be a very precarious sort of postdoctoral pathway for quite a while. And then, when you finally make it and you run a group of your own, you suddenly have to deal with having all of the people working for you being super precarious. So I think one of the things we've managed to do really well at the Turing is kind of grow the career pathway as the team has grown. And even though, like we started small and we weren't one of the first groups, we're now one of the larger groups. And I think this is an area where we've been sort of helping to kind of set the norms for RSEs in the UK. And so we've got a pathway that goes from a specific training role, so the junior role for folks that we are sort of bringing into the profession, and that's a 2-year role, but with a guaranteed permanent post at the end once you sort of show that you can operate at the standard level. Then we've got our standard and senior levels, which are still largely individual contributor. You're doing all your work on a project, but at the senior level you start to need to force multiply others, maybe take responsibility for the work of others and smaller engagements. And we have a sort of lead and principal roles, which are sort of start to be more about connecting the work and making it more than the sum of its parts. And between myself and the principals, we're the sort of leadership group for the profession at the Institute. And again, I think just even when you can't guarantee that everyone, there's never going to be 44 directors of research engineering. I think just having these pathways and knowing that and helping people develop towards them sort of really helps. And I think that's sort of another sort of factor here is it's really tempting to sort of hire people who are some unicorn, look for that person who can do exactly the domain and the method for the project you've got next. But I think something that's worked really well for us, and part of that is that we're a National Institute. Data science is very broad, it covers a lot of domains, but we've had great success in hiring smart, capable people who are clearly willing and able to work across a range and read into and learn across a range of different methods and different domains. And we've had success pulling people in from a very wide range of backgrounds and supporting them sort of to sort of learn on the job. And that includes providing sort of clarity about what that career pathway looks like, what they need to do for the next roll up, and to provide sort of safe, bounded opportunities to stretch into that next role, whether that's be the only red person on a project, start to lead someone else's work, but with a well-known sort of collaborator and on a project that's quite well defined, or start to get involved in defining sort of what a collaboration looks like. And again, I think we found a lot of success in both supporting people to carve out the shape of role that best fits them. When we were 3 or 4 people, everyone had to be able and willing to do everything. We're 44 people now. We've got 9 research programs at the Institute. It's okay if someone mostly works in 3 to 5 of those. We're still making a deal that when you come here, you're sort of giving up your own research agenda, and that you need to be willing and able to work across, a large range of the Institute's work. That's part of what allows us to offer permanent roles. But you don't have to be spread across everything, and you can have the opportunity to specialize a bit in methods and domains that are of most interest to you. And also, in terms of pulling the team together, we've made a conscious effort to interview and understand sort of the capabilities of people from different backgrounds outside of where we originally hired, and we haven't found any background so far that's been sort of less capable at picking up the work. And I think one of the things we need to sort of recognize, especially the larger groups, is that we have to be part of building the capacity and training sort of research software engineers, and bringing researchers some good enough practice to sort of best practice. And we shouldn't fall into the trap that you can often do, when you're trying to get a single research project sort of going, of trying to find sort of some person who's somehow perfect in sort of all aspects of the role. And then the final thing that I think is sort of really critical for us is team culture. And again, it's a huge part of what's helped us punch above our weight when it comes to competing with industry for jobs, for attracting candidates and team members. So a big part of culture for us is open and collaborative. It's not just about how we work, with researchers. It's not just about making our work published open. It's about how we organize ourselves as a team. As we've grown from a handful of people, and the Institute being brand new, to the Institute being 7 years old and us being sort of 44 people, we've had to sort of work out, what are job roles, what are bands, what are salaries, what are career structures, what does progression within your role look like, what does progression to the next role look like. And we've tried with all of these to be sort of really collaborative and really transparent, and talk with the team and ensure that they get their say, and that when we make a decision, we're sort of clear about what we've made and what trade-off we've made and why. And we ensure that when we then sort of implement that, in terms of whether that's how we reward people each year with progression, or how we run our promotion process, or how we run hiring and we make salary offers, that those processes can be seen and observed by the team to be the ones that we said we'd do. And this sort of served us, I think, well over the pandemic and in the transition to sort of hybrid working afterwards. Again, we sort of worked together as a team to sort of understand what the different views were and what would work for us. We sort of, we couldn't guarantee to support complete flexibility, because we didn't know sort of what would be needed for the project work. But as it turns out, the Institute as a whole has settled really well into sort of hybrid working. And I think most parts of the organization don't require even the sort of 4 days a month that we generally set as an expectation that of sort of being in the office. Another sort of important thing for us is empowerment. And I think part of this is about supporting people's development, in that career pathway element. But I think a big part of this is also recognizing, giving people some control over the work that they're doing, letting them sort of express their interests on the projects. But we also provide this 20% time, so we operate an explicit buy 5, get 4 model with all our sort of projects. And that extra day a week is sort of split in 2. 10% of that is personally directed professional development time to help people sort of learn about some things they might not get the opportunity to learn about on their projects, to partake in the wider intellectual activity at the Institute, reading groups and interest groups and seminar series and so on, to go to sort of conferences and workshops. And 10% is effectively volunteering time, but for one of the service areas that the team does for the Institute or for itself. And there's some of those that we absolutely have to do, and if we don't get volunteers, we will volunteer people. But for a lot of them, sort of how much we do of each of these things can ebb and flow with the interest in the team. And again, I think that ability to feel like if you care about something and you want to kind of move something forward and advance something, you have that opportunity to do it. And with all of these areas, it's very flat. There's no kind of hierarchy about who can sort of own something, and we try and push those responsibilities as low down the kind of seniority chain as we can. And again, it's a great way for people to both stretch those muscles of autonomy and responsibility, but also just sort of genuinely feel that they are in control of their work and that they have an ability to influence their workplace. And then the sort of final element that I think is critical for us is this sort of learning and growth, and that comes all the way from how we make our hiring decisions through to how we support people in their development, through the freedom we give people to sort of work on things and learn things that aren't directly related to the work that they're doing or the work that we've earmarked them for next. And again, with all of those things together, I think you sort of end up with that sort of sweet spot where people feel they're doing work that's meaningful to them, and that may, even in an institute where most of the work is socially good, that can be very different for different people, that they get to be good at their work and that they feel that they're sort of recognized as being good and for their work. And I think those three things together sort of make people feel very secure and happy in their environment, and sort of add to that that ability to have some strong input into how that working environment evolves. I think gives a sort of really attractive and kind of sticky environment when it basically we totally outcompeted on salary by not not even just the banks and big tech, by a large chunk of the kind of middle technical sort of teams outside of academia and government. So that's sort of all the things I wanted to cover, but I'll be very happy to take any questions people have.
Yeah, thank you very much for the excellent talk. Sorry, I pressed twice the button. Kim, would you like to guide us through the Q&A session?
Do you like me to stop sharing, or
you can, yeah, maybe stop sharing. I'm going to take a sort of chair's prerogative and start out with a question of my own. I want to know, so maybe if you can talk a little bit more about how the Turing does, or maybe could potentially in the future support postdocs and maybe embedded RSEs. So, RSEs who are in research groups and they're working by themselves without the benefits of a peer group, in skilling up while they're engaged in a particular research project. So, I mean, I'm thinking of things like, coaching. I mean, you already provide training, maybe opportunities to do some form of collaboration with people who are inside the Turing. So how do people like start engaging with the Turing? And are there any, maybe even ways that the Turing isn't yet doing that could help people who aren't officially part of the Turing? So this idea of sort of you're scaling up everything and trying to sort of spread best practices beyond your walls.
Yeah, so I think there's one aspect of that I think even applies within the Turing, which is our best engagements are ones where the researchers are better research software engineers and we're sort of better domain and method experts when we finish working together. And as we look at how we're going to focus our research over the sort of coming 5 to 10 years, we're sort of taking this challenge-led approach and looking to organize our work around these larger, more coherent missions. And I'm hoping that we'll end up with kind of much more tightly knit, larger, more diverse teams working on the same problem in the long run, and that we'll get a lot more of that, and that will be a very natural way for people who might come into the Turing as a researcher who want to kind of make the move to do so within that sort of team. We've had internal secondments to do that, where researchers wanted to make the move into sort of software engineering or data science, and I think we've supported something like 30 placements from outside the institute. Probably about half of those are through the government's fast stream service, or maybe sort of 30 or 40%. Another 20 or so percent from PhD programs, and the rest from other research software engineering groups. And some of those have been sort of really sort of fruitful. They've been a real win-win, where as well as that kind of knowledge exchange, which we all sort of perceive as really highly valued, they've been a great way to help some some teams at other institutes just get beyond that scaling hump. So we can, underwrite a little bit of work effectively, or we can help them, take the risk of hiring their first sort of focused on machine learning, even if they don't yet have an internal market for it. And so we sort of really found those to be super effective, and we'd love to do more of that. As we sort of look, one of the things we're looking to do as the other things we're currently doing are working as part of the RSE community. So several of our team are sort of trustees or otherwise involved in the UK's Research Society for Research Software Engineering. And one thing that's I think is becoming, I've seen sort of spike in lots of places this year, and I'm really hoping we can collectively, between the society and organizations like ours who are interested in it, is this sort of competencies sort of thing of saying, you know, what are the different, I think Jeremy talked a lot about it in his talk, which was, you've got all these different ways that you can be an RSE, you've got all these different places people start from, and so almost every combination of person and situation requires a slightly different set of infill to sort of make you ideal for the role you're in, or even the role you want. And I think there's a lot of opportunity for us to be much more than the sum of our parts there, by doing, you know, bits of work locally that are most important to us, but in a way that builds a more coherent sort of wider whole that others can sort of pick and build from. And I think something else we're super interested in working with the wider community on is on how we bring people into the profession, both in terms of overall diversity. We've done pretty good on backgrounds, but we've barely moved the needle on gender. I think there's also just how, you know, it's quite easy to hire someone after their first or second job, whether they've been an RSE or they've been doing RSE things in a postdoc role. Becomes a little harder to hire them sort of straight out of a master's, straight out of an undergraduate. You know, what would it look like to do an RSE apprenticeship? In the UK, our apprenticeships have evolved these on-the-job training sort of models, where you mostly work but you do a bit of schooling, have evolved so that you can get a degree at the end. So the UK is still quite snobby. So if you want to go in many places, including academia, not having an undergraduate degree for data science and software engineering broadly is really, really tough. I think as a sector, we also suffer a little from PhD snobbery. You know, there's this kind of, I think it's part of that model of what academic credit looks like. And so we'd be super keen to be part of that conversation, and what we'd love to be able to do. You know, we think it's how many things can we do directly ourselves? We can probably do tens of those a year at most. But, you know, how many, you know, with us working with others, how many new opportunities or sort of new roles can we help the community scale by establishing new groups, growing existing ones, you know, having lots of different groups provide sort of pathways in and development pathways. You know, that's got to be 10 or 20 times that. So,
yeah. That's really exciting. I'm just going to sort of like lead on. So just
I'll try to be more succinct.
you were talking about you've already got diversity in the group, but I mean, like, where do most of the Turing RSEs come from? I mean, do members? I mean, is it discipline diversity? And I'm also curious about, like, what kind of software engineering or programming experience people typically have when they come in. I mean, do you get people with formal training, or is it really that they've sort of like ad hoc learned a little bit of Python and now they're thrown in the deep end kind of thing?
We're mostly, well, we're not quite that extreme, but like I think it's mostly people who've picked these things up on the way. So in terms of, while we've got a lot of domain diversity, we're still most of our success, we're much more successful being comfortable appointing people who've come through the academic path. So we're quite comfortable hiring people straight from a PhD. But yeah, we want people to have been thinking about different domains, and we want people to have started doing some things on their own. If they've gotten to kind of good enough on their own, and they kind of understand sort of that there's better out there, and they've been kind of reaching that way, then that's great. We've had a reasonable number of people from industry, but I think we still do worse at that. And I think one of the things we really struggle with, that we would love other people's views on, is what is it that we really want from the R in RSE? You know, when roles say PhD or equivalent, yes, sometimes that's because you need it to be at a certain level, but, you know, in a research institute. But what is the thing that we really want from that? So many of the things people get from their PhD are just generic first technical job skills. But what's the thing that, you know, really puts the R in RSE? And what does equivalent experience in industry look like where you're not in a research role? You know, there's lots of industry research roles, but there's, you know, could we broaden that out?
Yeah.
But yeah, generally, our experience is similar to what Jeremy said in his talk. Most people are sort of self-taught. There's very few people with formal computer science in their background. We had a lot of, you know, physicists, I guess, early on. We're a much smaller contingent now. We've got psychologists, we've got, you know, folks from medical backgrounds, folks from humanities backgrounds, folks from geography backgrounds, and so on. But yes, mostly, I mean, I learned Python, and I mean, I knew other languages and I programmed professionally before, but I learned Python on my first project at the Turing, and R on my second job at the Turing, and those are probably in order the two languages for data science.
Yeah. I'm looking for hands up. I don't see any hands up at this point. If anyone wants to ask a question, now would be a very good time. Otherwise, I'm just going to jump back in again, as my want is. Going once. Okay, so I'm going to jump in. Just, I'd be curious to know your thoughts, Martin, on the publication co-authorship question. So,
yeah.
like, does the Turing have a stance on whether an RSE should be named as a co-author on a publication? Is there a sort of threshold of like how much R do you have to contribute before, you know, it's considered appropriate and actually morally, I would say, it should be done? And is it something that the RSEs who join the Turing care about, or maybe their thoughts change after they've been in the Turing for a while?
So, to answer the last bit first, I think it's a very broad range of how much people care about it. I think we used to say we can't guarantee you a path back to academia if you come across to RSE, but we've seen enough people move back, both at the Turing and elsewhere, that we think that's now a very sustainable pathway. We're generally quite good at the Turing. If you know, there might be sort of work that the researchers we're working with are kind of doing independently of us, and we wouldn't necessarily expect to be authors on that. But we would generally expect the work we're doing to produce papers, because that's kind of what matters to researchers, and we would expect to be on those. And generally we describe ourselves as middle authors for methods or domain sort of application papers. Although sometimes, you know, we're lead authors because we're sort of leading that validation or analysis work. But often we'll publish a methods or software paper alongside, and then we would often expect to be lead authors on that. So we would generally expect to be authors. In many cases there's plenty of projects where we're formally co-Is, and in others we're informally sort of playing that role in terms of leading the research engineering effort. And while maybe the work, the Turing's research isn't as what's the word, consolidated into sort of big areas as it will be in the future, we've generally not found authorship to be a challenge. There's occasionally the odd investigator who feels that their PhD student or postdoc needs like some single author paper or something. And I don't know if that's field specific, but that's not usually the argument we have. And we sometimes have an argument about how much time we spend reading into the research, and whether that's valuable. But that argument is always at the beginning. Once we start talking to people and they see the value of the fact we understand the problem domain, these sorts of concerns sort of go away.
I see a hand, but I just want to push you in a little slightly different direction to continue this in the meantime. First, you're talking about people leaving the Turing to get back into academia. You mentioned industry, and it's sort of quite attractive. Have you seen people leaving the Turing, going into industry, maybe coming back later? But I mean, does being at the Turing and learning RSE skills make more opportunities available to people who maybe came from a pure academic background, and then maybe they might want to go into industry next, kind of thing?
Yeah. So we've had, over the last 7 years, we've had 15 people sort of move on from the team. Although most of our growth has been very recent, so that's not the average tenure I think is still longer than in industry. We've had a few people go into sort of lecturing type roles. We've had people go and several people go and work in industry as research software engineers or data scientists. We've had people go and work in government. We've had some people go back to school. A few of our juniors sort of went on to do particular master's programs or PhD programs they wanted to do. And it's very easy to say that everybody went towards something rather than away from the institute. But I suspect that some people probably were more receptive to opportunities because, up until recently, we've had promotion to, even that first promotion from standard to senior capped. So we've had to maintain a certain profile to maintain our cost recovery model. And I think that's had a bit of tension. I think there's also a bit of tension around, because we don't pay quite as much as industry, and because our standard, well, even though we would be happy with someone being a standard forever, is not a forever salary in London, then I think there's quite a lot of feeling of wanting to sort of make that progress, and when people compare themselves to their peers in industry. So I think, I think that's probably affected, some of people's sort of moves. And I think that's just sort of reflected in that when we say standard and senior, we, in academia, I think we do mean something slightly different than the first step in industry. And we're just really seeing a sort of salary difference. But yes, we've seen people go in all directions. And one of the things we're really open with people about is, we want to develop them in their career, and their career might not be with us. We'd like them to stay with us. We'd like people to stay with us, but we'd always like people to have an alternative option. And I'd love all of my people to have standing offers from other places and be able to decide when it makes sense for them to move on, and when it makes sense for them to continue with us. We're pretty good now. We don't cap promotion to senior. There's still a little bit of difference between how people looking up at the role and people looking down at the role perceive it, and we're working on that. So sometimes people put themselves forward a bit early and get disappointed, but in general, we should be able to support everyone up into senior at least, and then it narrows to lead and even further principal.
So I didn't want to take too much time away from Peter, but now Peter's got his hand up. Do you want to unmute yourself, Peter?
Yeah, I hope my audio is working.
Good.
Just totally changing tack on the cloud, kind of first, or cloud native that you mentioned about your institute. Is this kind of cloud in the sense of the commercial cloud providers, and how do you how has that evolved? Because we use cloud, but mostly in the sense of our own academic clouds, in part because we find it difficult to cost in experimenting on cloud, commercial cloud,
Yes. So again, we were very fortunate. When the institute started, we had a partnership with Microsoft, and they gifted us up to $1 million of Azure credits every year. That gave us plenty of room to figure things out without like a huge cost pressure. We found the flexibility of the cloud to be really, really helpful, to give people the access to the compute they need. As we've started to pay for it ourselves, we have gotten much better at moving people off cloud GPUs onto some of these free at point of use sort of regional and national clusters, because yes, it's just like very expensive. The other thing we've gotten better at is sort of helping people deploy, rather than sort of treat it like a computer and set it up once and then at best turn it off every now and then. We help people to sort of deploy the infrastructure just in time to kind of do their computation, and then sort of tear it down after that. But yeah, I would say that probably most people would consider the cloud to be between 2 and 10 times more expensive than on-prem. On-premise, I think it depends what you count. I think it's very, very difficult to get a really good number of what the full economic cost of an on-premise data center is. Often people don't account for rent or even electricity or support time, whereas in the cloud your unit price is definitely covering everything and a little bit more. We also take advantage of sort of prepaying for capacity that we know we'll use across a range of projects, so certain compute classes and storage and so on. we get better rates for that pre-commitment.
So Kim, I know we're on time, but if I can just have a follow-up question, because this sounds great. It's just that, so this is kind of DevOps for research, right? This kind of deploy just in time. And how have you found, because how have you found bringing people on board with that? Because it's not like DevOps is something like kind of Python where you get the carpentries and all of that already doing the, do you have a special role for, I don't know, ResOps or whatever you want to call it?
So I think that's part of why we sort of label the research computing engineer role, with a separate name. To a large extent, the roles in the team are sort of fungible, and depending on how the institute's needs evolve, we would expect people to be able to work across things. But one of the things that we where we're looking for people, I guess we're looking for people who have skills, but also who are interested in this being part of their role, to develop those sorts of ResOps, research operations, DevOps type skills, to work with projects to kind of help them sort of do that, and to then upskill the researchers themselves. And we're doing much less good at that last bit. We're doing better at sort of making tooling that we can easily reuse. We're sort of managing to get some of our big users who sort of can see the value in reducing their cost by 80% by being preemptible, by being displaceable on the cloud. But it's still a bit of an upward journey, and I think we still got work to do to both make those to provide tooling that makes it really easy for people to do that, but I think also to provide some consistency of experience from laptop to cloud to these large, free point of use GPU clusters, or maybe CPU clusters for other, and non-AI workloads. And that's something that we're working with some of the regional high performance clusters on, and also has been a big part of what's been shaping the expectations for how this new AI research resource will be configured. And the expectation there is it will be a sort of private cloud, to provide that same flexibility, and that will look to provide a similar interface on across a range of platforms exposing GPUs, and that there'll be a variety of interfaces that will hopefully make it easier for people to make that step. Because we still do get people who are really at the scale where they, for cost reasons, should not be on the cloud anymore, but find it quite sticky because they're not used to sort of how the high performance clusters work. And yes, I think it is very much like the research systems engineer, and this role is us and a few others call it research computing engineer. I think quite a few UK RSE groups call it research infrastructure engineer, but exactly this how do we sort of run and support people effectively using computing hardware.
So I'm also aware that we're at time. I just want to read out, there's a comment saying, thank you for a very interesting talk, really inspiring working model. And I want to second that. I'm personally going to be watching the recording at least once, probably more than that in the future. So I want to say thank you again, Martin, for taking the time. I really, really appreciate it. I'm going to hand back over to Francesco now.
I can also thank Martin for the very exciting talk and very informative talk. We are trying very hard to catch up. So it's very good to hear the best practices in other parts of the world. So thank you very much, Martin. And I really hope that we will stay in touch, because as I mentioned at the beginning, it would be really nice to have also some kind of institutional interaction, not just around the research software engineering domain.